Hello, I'm Abraham Yakasan, a junior in electrical engineering.
And I'm Ryan Yang, a junior in computer engineering, and this is our project, the drill alignment tool.
Here is a still image of our project. Here you can see the assembly for our project. First, you have to insert the drill into the system through the bottom of our system. The drill is inserted into the hole and it is secured on the sides by the bolts. The bolts are then tightened, which fastens the drill into our system. Once the drill is secured, we can power up all of the electronics. Here we demonstrate how to power on the system. There are two plugs which need to be inserted into the power bank on the top of our system. One plug provides power to the PSoC, and the other plug provides power to the sensors on the front of our system.
To align the drill, the device takes distance measurements from 4 ultrasonic distance sensors, shown here. On the backside of the device, here's a push button used when calibrating the sensors. These 4 wires carry the signals from each sensor. The 5-volt signals are stepped down to 3.3 volts with a voltage divider, and then input to the PSoC with these 4 wires. These wires on the left come from the PSoC and are used to light the LEDs. Before drilling, the user must calibrate the sensors to correct any misalignments that occurred during assembly. To do this, place the empty drill on a flat surface, then click the push button. The green LED blinks 3 times for a successful calibration. If there is an error or the surface is out of range, the 4 yellow LEDs will blink.
Here is a full demonstration of our project. You can see the LED guidance system being used to align the drill with the wood. The 2 perspectives are to show that the drill is perpendicular with the wood being drilled into. Here is a demonstration of the LED guidance system. When an LED is lit, this indicates that the drill needs to be tilted in the direction of that LED. When the green LED is turned on, that means the drill is perfectly aligned. If all 4 yellow LEDs are lit, this indicates that the drill is at too steep of an angle for the sensors to function, or that the surface is out of range of the sensors.
Here we see a flow chart for the code that we use for our project. On the right, under the sensor labeling diagram, we see the numbering system that we used for the sensors in our code. Back on the left, we see that after we start the code, we set a counter variable equal to 0. We take a sensor reading from that sensor, and then we store the reading in a data array holding the last 15 readings. We increase our counter, which corresponds to moving to the next sensor, and then we take another reading. We continue this until we've reached the last sensor. At that point, we calculate the average of the last 15 distance readings from each sensor. Then we check to see if all 4 distance readings are equal. If they are, we turn on the green LED to indicate that the drill is aligned. Otherwise, we do another check to see if any distance was above 30 centimeters. If this happens, this means that there is a reflected reading from the sensors being at too steep of an angle, so we turn on all 4 LEDs. If the distances weren't equal to each other, and there wasn't any reflections, we then compare the left and right distance readings and the top and bottom distance readings to determine which direction the drill needs to be moved in to get into alignment. Then we turn on the appropriate LEDs to indicate to the user how they need to move the drill. We continue this process until the drill is perfectly aligned.